Hey everyone, welcome. I'm a new host for this month and I'm going to be hosting next month too. We like to pass it around to a few people. My name's Jonah Kowall. I'm the CTO at Logs.io and love to help out with the podcast. And I've invited a friend and colleague, someone that I enjoy speaking with all the time. Um, and Bartek, if you would introduce yourself to the audience, that would be great.
Yeah, hello. My name is Bartek Plotka, and I'm principal software engineer at Red Hat. And I'm super excited to be here today.
Cool, thank you. And I'm coming to you from Miami. And Bartek, where are you again? Just so that everyone knows where you're coming to us from.
Yeah, normally I'm in London, but now I'm in my family place in Poland, and this is Gdańsk, very north of the Poland.
Lots of awesome engineers from Gdańsk. So you're following in the traditions.
Yes, hope so.
Cool. So can you tell us a little bit about your background and what you do? Because I find it all interesting to hear that. So
Sure, why not? So my particular background, I would assess it as a software developer focused on like high quality, reliable, code, and this is kind of my passion and was from the very beginning. I was never a hacker, and what that means for me is essentially I was always slow programmer, right? If you would force me to participate in some hackathons like 24-hour game or application creation, I would probably would have the last place because I would be just setting my ID probably at this point. And it's just how it was forever. And I just enjoy very high quality, efficient programming when I, ensure I have a correct design up front and kind of complete the thing to the very end. And there were many people better than me who just are better to start things and hack things. But this is as it is. And yeah, I started working very early in my career. On the second year of my computer science studies, I started at Intel. So I was kind of grateful to join software-defined infrastructure division, which was very focused on, very cool hype technologies at that point. So I worked there for 5 years, and we did many performance-related products written mostly in Go for open source orchestration systems like OpenStack, Mesos, and then Kubernetes. And then, I joined UK startup in London called Improbable, and that's where I learned how to, run things on production. I was SRE, site reliability engineer there. And it was super amazing experience to kind of combine this performance theory, maybe background into like life. I learned how to be pragmatic and how to run 30 Kubernetes clusters around the world with beginning of the Kubernetes, by the way. So that was pretty rough. We had to run Kubernetes ourselves, for example. Now no one's remember about those days anymore. And then after 3 years of that, I just happened to join Red Hat, where I'm leading projects around open source observability on OpenShift and like for the community as well. And I'm also kind of on call from time to time doing SRE duties.
very cool. So I'm the opposite kind of programmer than you are. I'm more of an operations person, and I like writing terrible scripts for people to deal with versus well-structured code that's easy to maintain. And just another anecdote that I thought was interesting, we actually run our own Kubernetes infrastructure on multiple clouds. So people still are doing it that way, usually because they found too many bugs with the cloud services out there, which is our case. So we keep trying to get out of that part of the game, but we can't seem to break away.
Yeah. I think that's a holy grail sometimes, right? To get out of the lock-in, and you should maybe focus on designing your system upfront to not get locked. But it's a very complicated topic, and there were many. I think it's a controversial topic as well because there are many cases when you do that prematurely and kill your business because of that, right?
Yeah, it's a push and pull. I mean, obviously, we would want to spend as much of our engineering resources as possible building software instead of maintaining and dealing with building Kubernetes, but that it is what it is. But I did want to understand, I mean, it sounds like you used a lot of open source, but how did you actually get involved in the projects that you're involved today? And maybe you can tell us a little bit about the open source projects that you're involved in today, because there's quite a few of them.
Yeah, sure. So I'm kind of started my open source journey in 2015, and I was at Intel, and we have like a very good collaboration with Mesosphere at that point. That was a very a hyped startup that started to kind of adopt or allow people to adopt Mesos, which was kind of some kind of maybe not the parent of Kubernetes, but some orchestration system that started this journey of orchestration open source system. It was used by Twitter mainly, and we were creating some performance plugins, something noisy neighbors essentially, and I had opportunity to kind of contribute those plugins in open source. It was super new to me, and I need to thank here on record to Niklas Nielsen, who was working in Mesosphere at that point. Now he's kind of starting his own kind of business, but I mean, I still feel bad for the amount of time he spent on those code reviews. I was so bad, and he kind of mentored me into like I don't know, like good community friendly patterns and skills of even development in open source. So that was pretty cool. And then everything since then we were involved into open source, and especially when I joined Improbable, we used lots of open source tools. So for Kubernetes, to name one, but also Vault, Prometheus, of course, Helm a little bit, and lots of kind of Ansible, on all of those kind of stuff. And this was pretty great journey. And we also, that was the first time when I was leading kind of projects in open source as well, because we have, and I don't know how people experience there are different, but I exposed maybe 20 projects on open source, and I maintain it, but there was no single user. It was only me. But this is it. Like usually you expose your code, you share, and not every project has to be picked up. But at some point, we wanted to create a scalable solution for Prometheus, which we loved a lot. Like Prometheus was our core monitoring system. We have a lot of ex-Googlers and ex-Facebook people who are really passionate in having metrics. So this was kind of the direction we want to head. And we teamed up with Fabian Reynars, who were at CoreOS at that time, and created Thanos project. And, after 20 or 30 different projects we created, I created in my whole career, that was the one that was kind of hit the needs of the users and the other business and organizations, and this is why it got adoption, it got traction. So it's like with startups, you need to try different things, and not every idea is great, or not every idea is in the good moment. But this is it, and this allowed me to actually learn how to maintain a proper project that is highly used, and that kind of changed to be my full-time job. So initially it was my side job. I was not even paid for that. It was like a side thing that we did, and now it is like a full-fledged kind of project, and I'm having multiple people in my team who's helping me on that. So and people from other teams. So this is kind of I'm super grateful to be able to do that and still get paid. And I also maintain Prometheus because it happened that Thanos is simply using Prometheus code and making them distribute, and you can run essentially Thanos Prometheus components like alerting, querying, storage as a distributed system. So yeah, I think I love open source because it helped me to get open-minded, I think. But this is my background on the open source stuff.
Cool. So did you build Thanos specifically for your company, or was it more something that was kind of interested you you started building it and then people said, hey, I need that too? I mean, what was kind of the evolution of the thinking behind it?
Yeah, so we purely built that for our needs. Like that was the initial idea. And the problem here was that we tried different solutions, and Cortex was a very, very basic kind of form at that point. So we tried that, and it didn't match our expectations. But it was like very, very beginning. So now everything is changed. And then we met Fabian on some conf on KubeCon, I believe. And Fabian has this great idea because he created the whole database for Prometheus, which is used now in Prometheus, which is called TSDB. And because Prometheus have many versions of the storage, and he thought about kind of putting the same idea, the same format into cloud. So essentially using object storage instead of disks, and using native object storage API to accomplish the same task, but on higher scale. And we took this very simple operational model to Thanos. So it was, in principle, that was kind of Fabian's idea to go in this direction, and this is how we designed the whole system around. And to be honest, it's thanks to him that we were doing this in open source, but because Fabian was the person who was like, okay, I'm contracting with Improbable, we can do this, but it has to be open source. And it was a great decision at the end, because we have enormous help from the community. Like after 3 months already, we have friends from Fastly and the Cloudflare, who are trying to use it and doing lots of improvements. Then other company in London, Monzo Bank, started to use it. So it was enormous success. But yeah, it's, to be honest, thanks to Fabian, of very good idea in hindsight that he could be easy to operate and easy to use for everyone, and it just accidentally boomed. But the idea initially maybe was different. I think the outcome was great for both Improbable and the community, which is great.
Yeah, it's an interesting pattern. Like that concept, I think, I've started to see that same pattern emerge over and over again, which is like distributed querying and using object storage almost as like a cluster backend, right? Where if you run a lot of APIs at the same time concurrently, you can get pretty nice throughput from it, even though it's not designed as a high-speed I/O type situation. So it's a pattern I keep seeing over and over again. But I think that you were pretty early on the bandwagon in terms of like building that type of system, from what I saw.
Yeah, and I just want to mention that it's getting only better. Like those system evolves, and S3 was kind of, especially AWS S3, it's like amazing complex system that had really strong constraints on the APIs about rate limits, about how fast, how latency is there, what's the replication factor, and availability. But nowadays they're increasing this to the enormous sizes and scales. So it's just getting easier, right? The unfortunate fact is that because we build Thanos as you can use any object storage. Not all the object storages are equal, right? And there are open source solutions which are great because you can install on your own. But if you configure it wrongly or run it wrongly, then it's not strongly consistent, for example. So there are lots of challenges. But I think it's a really good solution. You can abstract so many problems away.
Yeah, for sure. So what do you spend your time doing on the project? I mean, I don't think you knew what being a maintainer meant a few years ago, but I'm sure you know what that means now. And I know that you've taken on a lot of additional roles and responsibilities around CNCF. So maybe you can talk about all of your balancing and then all the work stuff that you have to do on top of what most of us see you do for the community.
Yeah, sure. That's a good question. Yeah, I mean, everything I'm doing, I'm trying to challenge things, and sometimes probably too much, but I really like to, challenge some maybe tedious work or some inefficient processes. So we, for example, challenged the even Golang style guide, and we created our own, which is more strict and is streamlined and even more consistent than the casual style guides. And we are kind of improving those. We thought that maybe we can do something for the community in terms of diversity and kind of new people. So we are doing mentoring, and it was a great opportunity because we are part of the CNCF Cloud Native Foundation, Computing Foundation, and they are organizing lots of mentorships. And as a project, you are allowed to participate in that. And we have right now 4 students, for example, right now this quarter, and we used to have like 11 total. So I'm kind of challenging, just normal maintenance and just trying to reach higher and reach wider. So we are mentoring, we are teaching community, we are building community as well. So we are experimenting with different approaches. It was for example, in the very beginning, very hard to explain to the people that we should use Slack, because everyone, it's not asynchronous, you should use GitHub issues.
You don't like Gitter anymore, you mean?
Yeah, now it's Gitter. Sorry, I'm old school timer. Yeah. Now is, but anywhere, like, what I mean, it's like essentially chat synchronous base, and it is kind of enormous help for the community, because so many people were just afraid to put an issue, because an issue is a big thing. You need to find some form and kind of fill the details, and suddenly lots of cases, people are shy. They want to just ask maybe silly questions, and then they get encouraged and motivated to do properly things asynchronous. It's a game changer. You cannot even avoid that. So that was something we learned. But yeah, we are trying to kind of challenge every process. So we are improving, even website building. We build it ourselves, and we kind of host it from our, project, and we use Hugo and kind of automatic process that allows us to hold documentation in the markdown files on the Git. So every link works when you're just using GitHub. But when you build the website, and every commit, we build a website, and on the main repository of Thanos, for example, you actually have the same documentation, exposed, and the links works as well on the website. So people are thinking when you are maintaining big project which is like database, all your work is about efficiency. No, I was building websites, so it's kind of silly, but this is what sometimes you have to do. But yeah,
what's the name of the framework that you're using to build that? I just wanted to write that down. I didn't get the name.
It's Hugo. Like, that's kind of super nice thing. We use Netlify for hosting, and they have like amazing opportunity for open source project. You can just ask, and they will give you more resources, and they were super helpful. And we literally built the website on every commit, so you can preview the website and whatever. And I recommend doing that. And then there are different templates that you can use for documentation on Hugo. We use something custom, but yeah, it's pretty good. And then how many tools we built around that? I think we are getting into a very deep tooling kind of trajectory. But I would like to mention something else. I'm really passionate to even challenge, the database we are running right now. So, for example, we started the Prometheus storage working group, where we actually explore how to get the TSD database further. So to make it more, cloud native friendly, and make it even more work friendly to the object storages, right? So we are teaming up with Cortex, with people from Loki and Tempo, and Prometheus itself, to make sure we kind of find something cool. And I'm super happy with that, and excited as well, because this gives me opportunity to learn about cache oblivious algorithms and stuff around efficient indexing. And I think there is a lot of things we can do in the community, not mentioning some things we can learn from Monarch. So I think something I really, really wanted to add to Thanos someday is the query pushdown logic, where you are evaluating query on the leaf nodes, so like very deep to your storage, not in the federated layer. And all of those are some amazing engineering things that there is not much time for those things, but I would really love to improve those. And not to mention, kind of observability itself. We can always expand. We can always improve things. And, Thanos is just metrics, but we have, especially in Red Hat, obviously logging, tracing, and we would love to correlate between those easier and allow tools that will make it much easier. So that's another goal. And we want to extend the signals itself. We want to maybe bring other signals like continuous profiling, which is something we recently introduced in the Red Hat, and we love it. Like essentially, it allows you to we can debug performance issues much more efficiently.
So before you get into profiling, you did hit on something that was interesting, which is how do we talk about unifying the signals? And I know like exemplars has started to come forward. I saw it was part of the release, even though it's an experimental flag that you can enable. I noticed that in the release you just pushed yesterday or today, right? I believe of Prometheus. Mm-hmm. Can you explain a little bit about how people can use that today, or maybe where you see exemplars going? Because I think that's a great way to be able to bring together some of the metric tracing and logging data, it's really tough with metrics because it's all time-based correlation without some type of way to do that in a more definitive way.
Yeah, that's a good question. And actually, in principle, correlations, so the ability of quickly jumping through from metrics to logs and metrics to traces and traces to metrics and all the permutations is in principle it's very easy. Like you need to just have consistent metadata. And kind of all solutions are coming in this direction, which is amazing, and especially in the CNCF kind of ecosystem and even the whole open source Prometheus based, let's say, solutions like Thanos, Cortex, Prometheus, Tempo, and Loki, and even Jager. They're having the simple label mechanism. So for all of those solutions, if you set up tracing and logging and metrics, you are capable of having the same metadata to the application itself, to the container itself, right? So this alone gives you ability to just go from the metric to directly to the time frame and the application that was running for this metric that you see on the metric graph, and you can see all the log lines and all the traces for that particular application during that time. But that's not enough. We want to sometimes dive deeper and find out what exactly operation triggers some latency on my metric. So for example, that's a very common use case for something called exemplar. And how you use it, maybe let's start from the instrumentation, because it might be released. It's actually right now available in the newest Grafana. So we have a visualization layer, we have storage layer, we have collection layer, and we have instrumentation, but it's not very known. And the kind of tricky part about exemplars is that we need to now be very vocal and make sure everyone is aware that during instrumentation of your programs, so many people are using, for example, Golang library, Prometheus, client Golang, you are capable of just using the interface which allows you to push exemplar. And exemplar is essentially an information about example case that was happening during the increment of your metric. So for example, one increment of the metric could be, I have a specific 500 error. Like this is like very silly, naive example, but let's say I have a metric HTTP errors or HTTP like request, and then I have 500 status code label, and I increment that, 100 times. Maybe the same error is happening, so I'm putting the example request ID or trace ID or operation ID, like some hash maybe, that allow me to correlate that with my logging or tracing system. And there is like API you can do that.
So in Prometheus, the way that you store those exemplars seems highly inefficient versus time series, right? Because you can't compress it the same way, and it could be anything. It could be a log message, it could be anything. So how do you deal with that from a data structure perspective without blowing up the database when people go crazy with exemplars?
Sure. Yeah. I mean, very simple way. I just ignore most of it. Like the thing is, this is just example, like exemplar, right? By the way, it's not. Yeah, there was like naming kind of issue, but like exemplars. I don't know. Like it just it was very new to me, but exemplar essentially is like an example case of many. So even if you have 500 errors and 500 requests that were failing, I don't put 500 IDs. I can put 500 IDs, by the way. Like the API allows you to do that, but the storage, the metric page, which is exposed to your application when the Prometheus will scrape your metrics, it will only have the latest ID for this particular metric, right? So it just picks whatever example of one of those, right? And this is very enough because those should be a very similar request that you don't need exactly all of those. You want to just have an example that gives you flow of log lines or flow of tracing spans. And thanks of yeah if you want to say
So
something.
the idea is when you scrape it, you get one example of that. And you may scrape it once a minute and you're going to get a new example every minute, but you're not going to get all 5,000 of them that happen throughout the minute when your application was failing or whatnot.
Correct. And the storage part is interesting then because we just collected the last exemplar for the given metric. And this is what you can, right now, with the new Prometheus with enabled flag, you can query for that data. You can say, for this metric, give me exactly this exemplar ID or trace ID or request ID. This is exemplar API, HTTP API, similar to series and queries and whatever. The caveat is that this is a very first implementation of the storage, so it's not persisted. It's like in memory, and it's a circular. So you essentially have this data in for the fresh number of exemplars, but there is no longer retention or persistence. And in future, we are also we need to make sure this is replicated with the remote write and all of this. This is still coming. However, if you use Prometheus right now, you enable this flag, you spin up your Grafana with the 7.4, I guess, and later version, you enable this flag, and then you have an application that has instrumented exemplars. You can leverage that. You can literally have a graph with those little points that if you hover on it, it just shows you the metadata and this exemplar, which is trace ID or request ID, some kind of ID, you put it there. And then you can specify the link. It can be linked to another system, but actually Grafana wants to make it very nice. So they actually have some kind of Jager-like UI that you can actually, within the same window, you can open on the same screen like a column with just span of this trace for exactly this trace ID or logline or stuff like that. So it's pretty sweet in the principle. But yeah, just here for the record, please, when you instrument your metrics, think about exemplars and just add them, because it will be enormous help, because this is where the value is, right? You're writing application, you're exposing metrics, please expose exemplars as well so people can use it.
Yeah, we're doing some interesting work in Jager right now with the community where we're actually starting to add in the ability to analyze and display time series data, so basic metrics about a service. And I can see us as the next step, then being able to take these exemplars and link them directly to a trace ID, which I think would be pretty nice to see in the Jager UI too. So yeah, it's good to keep in mind.
Yes, I would need to check, but I think there is some work to be done on the client side. I think Golang has this support, but to be honest, it's not very easy right now because you need to cast to a certain interface. I think we can improve that. There is also, I think Python already have that, but I wonder other languages. Would be nice to kind of expose this wider.
And that's more of like a Prometheus thing versus an OpenTelemetry thing, I'm assuming. I don't even know if there's exemplars in OpenTelemetry either, and that's a whole nother discussion in itself in terms of the differences between OpenTelemetry metrics and Prometheus and OpenMetrics, right?
Yeah, hopefully we can have both. So we can make sure that OpenTelemetry instrumentation, I'm pretty sure they will have exemplars soon, but hopefully we can make it, we can streamline this and allow to those protocols to work interop essentially very easily. So I have a high hopes that this will happen.
Yeah, so you mentioned, switching back to your other topic, you started talking about profiling. Maybe I have my own idea of what profiling is, but maybe you could explain to the listeners what profiling means to you, and what are some of the things that you want to introduce in terms of profiling into observability and open source.
Sure. So profiling is just a way to learn more about your program, about what it's currently doing or what it was doing over time. And it's around, it's focused around resource usage and kind of a low level, profiles that you can gather from your running application, right? So it's a very common tool used when you are trying to benchmark or trying to find out the root cause of some slowness of performance, essentially bad performance of your application. So maybe the latency is high on the request, or maybe it's using lots of memory or lots of network calls, or maybe there were some race conditions. All of those can be, there is the only way to kind of narrow this down is to orchestrate some kind of log lines or traces, but this is very inefficient. Because you would need to put trace on every little internal function, and this is not the purpose of the tracing. So this is where profiling helps. So lots of programming languages allows you to set up some tooling where you, on a given, this is for example in Golang, every Golang application right now, if you kind of, there's like easy way to set up this. It's called pprof package in Golang. If you just registered it on the start of your application, you expose the endpoint, HTTP endpoint on your application. If you hit this endpoint, you can get the profiles of different things. So we can get a profile of, of CPU time. And this tells you how much CPU time each function did for the particular time. And the same is for memory. You get, this is called a heap. So essentially, because, it's very complex and applications are, reserving and using different kind of memory, heap, stack, mmap, caches. But heaps is the usual, the hardest thing to work with because of garbage collection and kind of a complexity here. So it's a very common source of like high memory utilization. So we can dump this and have a profile of each function, how much memory it used to use from the start of the application or how much it is using right now. And this is enormous help when you have something like memory leak, where suddenly your application is like never releasing some memory and just going up until boom, which is like out of memory kill. And all of this existed for a long time. You can actually profile Linux, right? And this is kind of the pprof standard that everyone talks about. There was pprof tooling as well, which allows you to, place those amazing diagrams of the functions, which is calling what. It looks like a tree, right? Or the flame graph, which is also showing you, what part of your program compared to how parts of the program compares to each other in terms of CPU usage or memory, right? And all of this is great, but it was not considered as observability because we usually consider observability as something continuous, right? We observe something for some time, and and then profile is like one thing you do and forget. And the problem is with that sometimes things are happening. You don't want to, sometimes things are happening and they happen in the past. For example, the leak happened in the past, or application just crashed and with out of memory signal, and then it's kind of too late. You cannot grab a profile at that point. So that's why the whole concept of continuous profiling started. And this was actually, even we talked about that within Red Hat, and especially Frederic started this in the KubeCon keynote. I don't know, in where it was Barcelona, I think, or something like that. Like 2 years ago, there was a keynote about what is the next things in the observability, and he mentioned the signal. And actually, he started the project called Conprof. You can kind of Google it, and it is on GitHub, open source. It's kind of a Prometheus converted into storing profiles, not metrics, but it actually works great. We use that on production, and actually Frederic started a company for based on this product. It's called Polar Signals, and long story short, it's an enormous help because it essentially scrapes this pprof endpoints, like pools, like Prometheus, every given interval. For example, every minute or every 5 minutes. Every minute would be better. Every minute you have a profile. And then, when something happens, you just go back, query the profiles you have and say, okay, this is the time I'm interested in. And then look, during this time, I have used 20 gigs of RAM and on this function, right? And then it was so I know where the leak is. And exactly, I have a code line with exactly line of the number. And I'm pretty sure in future you can have some integrations with your ID, and the click on the on the profile, and you go to your ID and fix the problem.
So it's funny that you mentioned this, because when you look at APM, which is foundationally is built on distributed tracing, profiling is a key part of APM and has been for 15, 20 years. But they mostly, and they capture call stacks. They capture information about when it's a virtual machine like Java. They capture all kinds of metrics about the JVM itself and how it's performing. And so you actually get that. The tricky part of it is how you do the sampling. So which requests you actually want to collect all of that data for, because it is a lot of data. It's hard to analyze. It's hard to break down. I mean, I think it's pretty elegant to do it with Prometheus, where you're just capturing the time series metrics on certain functions, but it can also get overwhelming. I mean, some of the call stacks that you see happening and what functions you actually want to pay attention to, it can be a lot of data. And if you're going to send all of that data to a central place, it can also cause, other performance issues itself. So profiling always has overhead, right? I mean, there's some type of overhead depending on how you're capturing it and how deep you go. I found it pretty interesting back in the days of Open Census that Z Pages was part of that, because that seemed like a really lightweight profiler. Did you look at Z Pages at all, or are you familiar with it?
With Z Pages, I know Google have lots of those pages ending up with Z, and we use that in Improbable, build something like that. And I really love this idea where you have a central location, sometimes even full UI, that allows you to trace things. And again, it was not stored like persisted. You could see lifetime what is you could see live what is happening, and I think that's a very good starting point. But at the end, we don't want dashboards, and that's not our primary, maybe a goal when you are monitoring a large system, because we don't have enough humans to just look on those dashboards. We need kind of some alerting and dashboards when we need them, and just for a short duration. And that's the problem with those kind of one live things that you need to, kind of reproduce to see what's happening, right?
Yeah, alerting is a big challenge, because like everyone's alert manager configs or alerting configs get pretty out of hand. We definitely need to do better with alerting and open source in general, just in terms of like making it more automated, like show me anomalous data, show me notify me when bizarre things are happening within the data. There are definitely ways to do that type of anomaly detection that I think would save a lot of pain in alerting config, just speaking of alerting. So
yeah, totally. But maybe before we move to alerting, I want to kind of share some cool stuff you can do with continuous profiling, because if you suddenly store them, store the profile of your application every minute, now you can derive metrics from that and have additional useful source of performance metrics. You can actually derive a metric for memory used by single function, which is super interesting to you. And now you can export that to Prometheus as well. And this is kind of already available on Comprof, if I'm not wrong. And also what you can do, it's not very known feature of pprof. And by the way, pprof is a standard. Like Golang just happened to use the standard, but you can totally have Linux in the standard. So every tool that works with this pprof, and hopefully, I hope Python people and Java people and C++ people have the same functionality. I'm pretty sure they have of pprof, exporting pprof, but essentially it's like a common format, and it allows different diffs. And this is super great. So you can get the profile of your CPU pattern for from the yesterday, and then get one from month ago, and you can kind of merge them and see the difference. And you can see as long as your code didn't change a lot, you can see some kind of patterns of if your profile is huge, right? So there are so many kind of flexible things, and I don't know about the performance overhead. Like we can talk about that, but I believe tracing could have more performance overhead at the end, because you are, I don't know.
It kind of depends on how much sampling you're doing and how much data you're collecting. Always, like, the more data you collect, the more overhead it potentially introduces. Obviously, the tracing is in line within the transaction. So when your code is producing trace data, it's potentially not executing business logic that it's supposed to execute. At the OS layer, when you attach a profiler to a running process, the overhead is small, but it has some type of overhead and impact. Similar to when you start scraping all these metrics, you think about a typical operating system, it's 200 to 300 time series, right? When you're typically scraping a host, you add all this profiler in, and all of a sudden it could be like 10,000 time series, right? For a simple host. So you could see how it might be, you have to use it pretty selectively, and you have to figure out exactly what the best practice is, what you should capture. Otherwise, it can really blow up your time series count for sure.
True. Yeah, and this brings us, I think, to the most complex part of the observability, is that you can easily pay more for your observability than for your workload that you are monitoring. And I believe this is the main problem with observability nowadays, is that there are so many ways that you can set up all the observability signals, but you can overdo that pretty easily. You can essentially gather more than you need, and you can over-engineer that so easily and pay more than for your workload, and actually slow down your workload maybe, and even kill reliability of your code. So
that's why I love the quote that Netflix is a logging company that streams movies. Like, that's the best quote ever, because you think about the amount of logging data that a company like Netflix generates, and it's probably more data than all the movies that they're streaming. So it's crazy to think about it. And we deal with customers all the time. I was talking to a customer of ours today that's sending 10 times more log data than they're paying for. And we're like, hey, you may want to try to fix this, because, you're kind of going crazy with the logging, and, people will go and do what they do, right? I mean, that's a big problem.
Exactly, yeah. So I would like to definitely make it highlight this, that if you would like to set up a tracing for your application, and just think about that, you have one request that has to be computed, And now you are orchestrating a tracing. So you are making sure there is a span on the entrance, and then there are maybe a couple of spans for following request. And at the end, you have, let's say, 10 spans for each request. So suddenly you generate 10 times more load, computation kind of load that has to be somewhere stored, collected than your requests. And you need to be very careful with that and do it only for the things that really matters. It's like with optimizing and performance and efficiency. You can do it prematurely and waste a lot of effort and time. So really be careful of that. I would really suggest that. But yeah, it's also super useful. So you need to have a balance.
Yeah, and I mean, the nice thing is now that we have more sophisticated sampling, I've talked to lots of people in the Jager community and also in our customer base where we want to store, which is obviously the cost. We want to store and send 5% of our traces, but I want 100% of our errors. So like you can do more sophisticated sampling after the transaction executes, where you can send the things that matter most. Send me only paying customer traces because I have a tag in my code that says this is a paying customer. And if they're on a free plan, give me 10% of those traces because they're not as important to my business. So you can do a lot of more sophisticated filtering with traces where you can use business logic to do more sophisticated sampling, that makes it more efficient than logging, which is it's hard to do really efficient logging. It's kind of there as a last resort when you're trying to fix something and it's tricky to do like crazy dynamic logging stuff. So cool. So was there anything else you wanted to cover off? We have a few more minutes if we want. I had a couple news items I was going to share with the audience after, but did we cover off everything you wanted to chat about with profiling? Any other topics that you wanted to touch upon?
No, I think it is super great what we did,
Cool.
and hope we clarify a bit of those observability signals and correlations and a potential of new signals, because profiling might be one. I heard about the crash or stuff like that, so maybe we can play with it.
Cool. Sounds great. Well, it was awesome to have you on, and so much exciting things going on in the surrounding Prometheus community, and what you're doing with CNCF is great with the SIG and getting people to talk through all these issues and differences in opinion. It's important that you make yourself heard, and I think you're doing great things for the community. So thanks for coming on, and thanks for making open source better, because it's good for all of us. And I wore my Prometheus shirt for you today. So
yeah, thank you for having me. And yeah, it's a great pleasure to speak, especially in these COVID times. I think we need more, social activities. So I'm super cool. It's like a pub these days,
Yeah, for sure. Cool.
Okay.
Thanks. Do you want to stick around for the news? I had a couple things I was going to share. If you want to comment on them too, that's cool. Otherwise, I'll do it myself. Up to you. So you can stick around and
yeah, perfect.
Yeah.
Go for it.
So I did want to touch upon two quick topics that were for the kind of news this month. One is for those of you that haven't paid attention, OpenTelemetry is in 1.0, but it's still in the sandbox, meaning it hasn't graduated. There's a bunch of issues around OpenTelemetry, one of which is that there's still a lot of work to be done. Metrics is early, but it's out there. Logging is still not even defined really. We're still working on SDKs. There's a lot of other things that need to happen. So although we suggest people to use OpenTelemetry for tracing where it's mature, it's still not there for some of the other signals. So it's got more growing up to do, but plenty of people running it in production. So that's good to see. But this is a big project, and I I don't think we're going to even see logging this year. That's my prediction, but I don't know. Do you have a prediction, Bartek? I know that you pay attention to what's happening with OTel, but
yeah. So I kind of forget to mention that you're welcome to join our Seek Observability, so special interest group in the CNCF that focuses on the observability. We do lots of different things, and we sometimes review projects if they are should be recommended to the incubation or graduation or different levels of the CNCF. And yeah, I had the pleasure to look into OpenTelemetry more, and there is like huge scope and like huge goals, and like this is very ambitious and this is amazing to see, but there's lots of work. So I think there are so big and so active nowadays that if you start spelling word observability, you are in the goals of the OpenTelemetry, and that's good. That's good because we are innovating in this space, and I have really high hopes and some cool ideas what we can do. So my prediction is that we could use soon metrics with OpenTelemetry collector that are not only receiving OpenTelemetry metric spec, so pushes, but also those OpenTelemetry collector can natively scrape and use Prometheus engine scrape engine directly with the same discovery mechanism or similar, and even operators, so like cluster resources. So it's looking to be great, and then it will forward, essentially will work like an agent that can scrape metrics, and the ideas are to make it scalable and kind of auto scaling, and I'm looking forward for that, and I would love to help as well. So it's pretty good.
Yeah, we've been testing it out. It's still pretty buggy, the scraping and the config and other things like that, but I think it's going to be a really nice capability to have. I also posted, for those that are watching on YouTube or Twitch, I posted a link to the meeting notes for SIG Observability with Bartek, which Bartek runs over at the CNCF. And you can see what's discussed. You can see the meeting times. You can see the Slack to join. So it's definitely a great community for discussion across all of these different tools that are being built and used in open source. So definitely suggest showing up. There's a lot of end users that come to those discussions, which is great to see. And it's definitely a worthwhile meeting to attend. So take a look at the Google Doc that's posted, and you can see what happens when the meetings are, and definitely join up. So, sorry, did you have another comment before I move to the next
I just want to comment on you're being brave to already try to run it, because it just started like 3 weeks ago, the whole initiative to bring like Prometheus capabilities into OpenTelemetry, and it will take time. Prometheus was stable after 5 years or something, so it is an enormous chunk of work. So please also contribute to OpenTelemetry, help that go. We have OpenTelemetry working group on Wednesdays, so yeah, you can join on those fronts.
Yeah, so I mean, the reason why it's great for us is because, as you know, we have a Prometheus service, and so the easiest way for people to use our service is setting up remote, right? Which means they still have to run Prometheus, but we have lots of people coming to us saying, can't we just put an agent, scrape the endpoints, send it off to a remote write endpoint, which is exactly what OTel will do when the scraping works the way it's supposed to. So that's going to be great, because then people won't have to run all of that other stuff, and they can still use Thanos. They can use our service, any of the other compatible services that use remote write. So I think that's going to be a great alternative to people that don't want to run all the Prometheus instances everywhere. So cool. So the other item for those that are using ELK or the Elasticsearch stuff, AWS is doing a fork, because, as those of you may know, Elastic has changed the licensing. It's no longer open source. And a lot of other companies are concerned and want to use open source. AWS has been working on cleaning up the code and getting it ready. It's going to have a new name. They're not going to be Elasticsearch and Kibana. Instead, they're going to be renamed. We're expecting that to be announced sometime, hopefully in the next week. The community's been a bit challenging around AWS. They haven't really been as open and communicative with the, with regards to the governance of the community. So that's been really concerning for a lot of people in the community, including myself. And we hope that that changes and that we have a great, vibrant community, hopefully part of CNCF or Apache. So that's the goal. And we're definitely pushing in that direction. So stay tuned, probably some news in the next 1 to 2 weeks from AWS, and we'll see where things go with regards to these important open source projects. So you probably don't deal with that a lot, Bartek, but if you have comments.
No, I mean, why? We are in open source, so we do everything in Red Hat in open source. We have our production configuration as well. So licensing is a true nature of business. It's really difficult these days to monetize open source and be very friendly to the community. It's just hard because it sometimes collides, and it's you see those things. And I'm pretty positive. I think it may benefit both communities. So for example, those who want to be very close with the Elastic itself, and those who are trying to maybe help the AWS fork to drive it, because it brings innovation, right? They might go different ways. They might, like the same as Thanos and Cortex. It's actually beneficial more than we think. So I'm pretty positive. What's your bet on the name?
Oh man, I don't even want to guess. I'm guessing that they're going to keep the first letter and think of some other name. Obviously, they're dealing with trademarks, so I think they want to keep ELK intact, but who knows? I mean, it could be something completely different.
Okay, like Dynamic Search 43. That's my bet.
No, I mean, it would have to be start with an E, so it would be like...
No, I don't know. If that's... Yeah, maybe that's trademark too, so who knows? Elk.
Yep, that's for the lawyers to figure out.
Cool. Let's focus on the technical stuff.
Yeah, exactly. We have a lot of cool features we're actually already building on the new fork, and I think there's going to be a lot of great innovation, because you're not going to have this commercial conflict where, we want to put that in our paid product, and so you can't have it in the free product. And so I think there's going to be lots of great open source innovation, because there's no conflict anymore. I mean, both what we do and AWS and lots of other companies, we build a cloud service. So making the on-prem version great isn't a problem for us. I mean, if anything, it's good for users to be able to use the stuff. And when they want a scalable service, then, they go and find a company that helps them do it. That's all. So cool. Well, thank you once again, and thanks for your commentary. And hopefully we'll have you on again in the not too distant future. And maybe we can meet in person, because we haven't before, even though we talk a lot. So well, thanks once again, and appreciate all your contributions and the work you do in the community.
Yeah, thank you for being open to open source as well as a vendor, right? I really appreciate your contribution as well. You are one of the not many vendors who are really focused on being friendly to the ecosystem and giving back. So that's that. Thank you for that. And yeah, hope we can get diving together someday.
Yeah, that would be awesome for sure. All right, well, I'll leave you to your evening. Thank you for working late for the podcast, and talk to you soon.
Thank you. Bye-bye.
Bye. Thanks everyone for joining us. Take care.